This is practice problem number 1 from lesson 12, Systems of Equations, and unit 4, Linear Equations and Linear Systems. So in this problem, you're given the graph of an equation, and you're to write a second equation that has infinitely many solutions in that system of equations, so the two lines, the two equations, or write a second equation that has no solutions in that system of equations, or write a second equation that has only one solution in that system of equations. And so to write an equation in the slope-intercept form, you need to identify the y-intercept, which in this case is 4, and then the slope. And the slope is how much this line changes along the y-axis for its change along the x-axis. In this case, it's changing in -3 units along the y-axis. So the length along the y-axis is -3 for 4 units change along the x-axis. So that's a +4. So this is a -3 units along the y-axis for 4 units along the x-axis, and you can rewrite that as a slope of -3/4. So what that means is that for a single unit along the x-axis, it changes a -3/4 of a unit along the y-axis. And this is the same slope triangle, identical slope triangle slid down here. So for every 1 unit change along the x-axis, there is a -3/4 unit change along the y-axis, wherever you are. So in the equation, to calculate the y-coordinate, you take the number of units along the x-axis and you multiply it by that -3/4. Because each unit along the x-axis, this line goes down in -3/4 units. And that amount then gets added to 4. So you're moving away from this 4, you're moving down by that number of x units times a -3/4. For part A, you are to write a second equation that has an infinite number of solutions with the first equation. So to show that, I'm just going to extend this graph out a little bit. I'm going to write the slope 2 times. So for every 4 units along the x-axis, this goes down 3 units. 4 units along the x-axis, this goes down 3 units. And from this, you can see that you can draw a scaled copy of that slope triangle that has a scale factor of 2. So for every 8 units, this slope triangle goes down 6 units. So it is just an equivalent fraction to the first slope. So 6/8 is an equivalent fraction of 3/4. And so now if you use that in the equation, this equivalent fraction of a -6/8, you set those two expressions equal to each other, and you'll see that the difference in the y-intercepts is 0, and the difference in the slopes is 0. And so if I solve for x, I am going to get an answer out of x equals x. So it's the same equations, an infinite number of solutions. So whatever value I choose for x in either of these equations, I'm going to get the same value for y. So there's an infinite number of choices for x, and I'm going to get an infinite number of values of y. For part B, write a second equation whose graph goes through 0, 1, so the system has no solutions. No solutions, that means that the lines are parallel, that they never intersect. So here's the first graph. And so the second graph is going to go through 0, 1 right here, and it's going to be parallel with the first graph. So it will have the same slope. And so to write the equation, the y-intercept is at 0, 1. So the y-intercept is at y equals 1. And the slope is the same. It's a -3/4. So these two lines are parallel. They never intersect. So therefore, they never have a solution. There's no solutions to this system of equations. So this slope right here says -6/8 equals -3/4. If I start at 0.01 here and go out 8 units along the x-axis and down 6 units, 1, 2, 3, 4, 5, 6, that's a -6 units for 8 units along the x-axis, which is the same as a -3/4. So if I set these two expressions equal to each other, it's a -3/4x plus 4 equals a -3/4x plus 1. And if you solve this, you're going to get rid of this negative 3/4 x on both sides, and you'll end up with 4 equals 1, which makes no sense. So there is no solution. So notice that the difference in the y-intercepts is 1 minus 4. It's a negative 3. So this 1 minus this 4 is negative 3. And the difference in the slopes is a negative 3/4 minus a negative 3/4, which equals 0. So there's no difference in the slopes, yet these go through different y-intercepts, just 3 units apart, so they never intersect. So equations for parallel lines, no intersection, 0 solutions. So parallel lines, different y-intercepts, no intersection, no solutions. Now this is the answer for part B. And I'm going to go into some more detail on showing you what happens as you move from a line that's horizontal to a line that's parallel with the first line. Just so that you can see that movement, go through the calculations, understand what's going on. Okay, so here's a horizontal line that goes to that same point. 0, 1. And if you start changing the slope gradually so that it's closer to a slope of a negative 3/4, there's less and less of a difference between the slopes of these two lines. So this line, there's a significant difference. This line, there's less of a difference. It's getting closer to negative 3/4, so less of a difference, until finally the line is parallel. So I want to go through those calculations. So it's good to take a look at the numbers and to understand these calculations. So if you start out, the difference in the slopes is a negative 3/4 minus 0. So here's the first line. Actually, this is the first line, the original line. And here's the second line right here. It's horizontal, and it goes through 0, 1. So it has a slope of 0. So that difference is a negative 3/4. It is negative 3/4 minus 0. So this slope is negative 3/4. Minus 0 is equal to negative 3/4. That's a large difference. So the difference in the y-intercepts is negative 3. And so the intersection, when you do this calculation, you're going to take the difference in the y-intercepts and divide that difference by the difference in the slopes. This tells you how much these two lines are moving together for each unit along the x-axis. It's a negative 3/4 for each unit of x. It goes over one unit of x, down 3/4. Goes to another unit of x, down 3/4. Another unit of x, down 3/4, a negative 3/4. Another unit of x, a negative 3/4. So how many times does that happen until they intersect? Well, that's a division problem. That's this negative 3 divided by this negative 3/4. So here's the negative 3 units right here. And here's the negative 3/4. How many of those negative 3/4 are there? There are 4 of them. So it's 1, 2, 3, 4. So that's the answer. X equals 4. So the difference in the y-intercepts is negative 3. The intersection, the solution, will be at that negative 3 divided by the negative 3/4. Now you can change that to positive values because a negative divided by a negative is positive. So 3 divided by 3/4 is the same as 3 times 4/3. These 3's cancel and you get an answer of x equals 4. So sure enough, you go out to x equals 4. What do you have to do to get to the line? This intersection is 4 and y equals 1. All right, so lots of words there, but hopefully you're just seeing this idea that this difference in the y-intercepts divided by the difference in the slopes tells you where this intersection is. So let's look at that some more. Let's go down, let's look at a slope of negative 1/8. So I'm going to go across 8 units. This is 8 right here, and down 1 unit. So this has a slope of negative 1 for 8 units along the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, down 1. So the slope of a negative 1/8. So what's the difference in the slopes? Well, it's that negative 6/8, which remember is the same as negative 3/4, minus that negative 1/8. So it's 1/8, a negative 1/8 less, closer to negative 6/8. Well, that answer is a negative 5/8. Lots of words. The difference in the y-intercepts is still this negative 3. But now this line is moving closer to this line at a rate of a negative 5/8 for each unit along the x-axis. This is a negative 5/8 closer, a negative 5/8 closer, a negative 5/8 closer, a negative 5/8 closer, until finally it intersects right here. So if you might look right here, and you can imagine that negative 5/8 is just a little bit more than a half, and that's what this is right here. So the intersection, the solution is that negative 3 divided by negative 5/8. How many times can I do that? How many times can I take a negative 5/8 out of negative 3? Well, that answer is 24/5. 3 times 8 is 24/5. That's equal to 4 4/5. So x is equal to 4 4/5. Y is equal to 2/5. I'm going to show you how to calculate that in a little while. But right now, just take my word for it that this y value is 2/5. So let's do that again. So now the slope is a negative 2/8. Was negative 1/8. Now it's negative 2/8 because it's 8 units along the x-axis. It's 2 units along the y-axis and negative 2 units. So the difference in the y-intercepts is still this negative 3, but now the difference in the slopes is less. It's a negative 1/2. It was a negative 5/8, and now it's smaller. A negative 1/2 is a smaller difference than a negative 5/8. So how many times can you take a negative 1/2 out of a negative 3? That's the same as 3 times 2 equals 6. So now you go across, that intersection is at 6, and this is, I believe this is negative 1/2. Again, I'm going to show you how you calculate that in just a moment. But the point is that x is equal to 6 at this intersection. Let's go down another 1/8. So this slope is a negative 3/8. So this difference is getting closer and closer and closer to negative 6/8, to this slope right here. So now the difference is smaller than a negative 1/2. It's a negative 3/8. The difference in the y-intercepts is still the same. So it's that negative 3 divided by negative 3/8. Well, that's the same as 3 times 8/3, and that's x equals 8. So this intersection is at the value of x when x is equal to 8. And y is negative 2. So this is 8, negative 2. And again, I'm going to show you how to calculate that in a moment. Let's go down another 8. So this is a negative 4/8. I'm going to extend this out so you can see where this intersection is. It's out here at 8, 9, 10, 11, 12. So the point is that this difference is getting smaller and smaller and smaller, which means that you can take more of those units out of this negative 3 here, the difference in the y-intercepts. That forces x to be larger. You can get more of those things out of negative 3. So x is getting larger and larger and larger. It's going out here farther and farther. So the difference in the y-intercepts is still negative 3, but the difference in the slope is smaller. Now it's a negative 2/8. It's the same as a negative 1/4. It's getting to be a smaller and smaller piece. So that 3 times 8/2 is the same as 24 divided by 2 is equal to 12. And that's what we said before. X is out here at 12. So the difference in the slopes is getting smaller, which means you can take more of those pieces out of this negative 3 units up here. All right, so let's go one more unit down. So this is a slope of a negative 5/8. Remember, going out here along the x-axis 8 units. This is 1, 2, 3, 4, 5. And it's off the page now. Where these two lines intersect is off the page. You can see that they're moving towards each other, but it's going to be way out here at 24. So the difference in the y-intercepts is negative 3. Take that negative 3. How many times can you get a negative 1/8 out of negative 3? That answer is 24 times. So x is going to be equal to 24. And to figure out the y coordinate, I'm going to just do this a couple of times. So take the equation, And so y equals a negative 3/4, x is equal to 24 plus 4, negative 18 plus 4. So y is going to equal negative 14. So this intersection way out here is going to be x is 24. Y is going to go all the way down here to negative 14. All the way down here to negative 14 is where it will intercept. All right, so what happens when the difference in the slopes are 0? So they have the same slope. So this is a slope of negative 6/8. So that difference in y-intercepts is still negative 3. But now you're going to divide that by the difference in the slopes. Well, the slope is not changing. This line now is no longer getting closer to this line. It's staying the same distance apart because the differences is equal to 0. So it's negative 3 divided by 0. Well, that's undefined. You can't divide a value by 0. So it has no solution, undefined, no value of x, where lines intersect. So there is no solution. So this difference is getting smaller and smaller and smaller and smaller until there is 0 difference. That's when there's no solution because you're dividing by 0. So no value of x where lines intersect. The two lines are parallel. And notice that a negative 6/8 is equal to negative 3/4. They are the same. So here I'm going to go beyond this parallel line, so to this line. So the slope of this line is negative 9/4. So if I start at this point here, that means I'd go out 4 units, 1, 2, 3, 4, and down 9 units. So for 4 units along the x-axis, it would be negative 9 units. That goes off the page. That's down here off the page. So let's look at half that. So let's go out 2 units. That means it should intersect at a negative 4.5. 1, 2, 3, 2 units, 1, 2, 1, 2, 3, 4, and 1/2 right here. So this slope is a negative 9/4. It's a negative 4.5 over 2, which is equivalent to a negative 9/4. All right, so what's the difference? Now notice what happens is the difference in the slopes is small. It's actually getting larger. There's more of a difference, but it's still pretty small, but it's a positive value. So it's a negative 6/8 minus a negative 18/8. So negative 9/4 is the same as a negative 18/8. That's a positive 12/8, which is the same as a positive 3/2. So now the difference in the slopes is positive. So when you divide that negative 3 by a positive value, you're going to get a negative answer. All the answers over here were positive because you were dividing by a negative 3 by a negative difference in the slopes. But now this is a positive difference in the slopes. So negative 3 divided by a positive 3/2 is equal to a negative 3 times 2/3 is equal to negative 2. So if you go out here to this point, the point of intersection is at x equals negative 2. And what's y? We take this equation and replace x with negative 2 and work through the calculation. You're going to get y equals 5.5. So this is out at negative 2, positive 1, 2, 3, 4, 5.5. So as you go beyond here and go farther, the difference in the slope is going to get larger and larger and larger, but it's going to be a positive value. So you're going to get fewer units taken out of this negative 3, which is the difference in the y-intercept. So that intersection is going to get closer and closer and closer to this vertical line as this slope gets steeper and steeper and steeper going this way. All right. So the second equation that has for which there's no solutions is the y-intercept is 1. The slope is a negative 3/4. This is just repeating the answer that we got before. So the difference in the y-intercepts is negative 3. The difference in slopes is 0. So 0 difference in slopes. So the equations for parallel lines, there's no intersection, 0 solutions, because that negative 3, this negative 3 right here divided by 0 is undefined. You cannot do that. Slope of negative 3/4, slope of negative 3/4, parallel lines, different y-intercepts, no intersection, zero solution. So this is the answer to part B. Again, same slope, different y-intercepts. So for part C, you are to write a second equation whose graph goes through 0, 2, and so the system has one solution at 4, 1. So the x-coordinate is 4, the y-coordinate is 1, and a solution means that both graphs, the graph of this first equation, which in each case is y equals to negative 3/4 x plus 4, that graph and this graph, the second equation, goes to this same point. So the solution is at this coordinate, at this point, x equals 4, y equals 1. So here's the first graph, the first equation, and here's the second graph. So it goes through 0, 2 and 4, 1. You see at point 4, 1 that both graphs intersect. So that is the solution to that system of equations. X equals 4, y equals 1. So the slope of the first equation is a negative 3/4. So 4 units along the x-axis, a negative 3 units along the y-axis. And the slope of the second graph is going to be a negative 1/4. So for 4 units along the x-axis, it goes down 1 unit. So that's a negative 1 unit along the y-axis. So now you know the y-intercept and you know the slope. So now you can write the equation. So the first equation we've already done. Slope is a negative 3/4, that's a negative 3/4 x, and the y-intercept is 4. So the second equation, the slope is a negative 1/4, so it's a negative 1/4 x plus 2. So the y-intercept is at 2. So if we set these two expressions equal to each other, pretty soon we're going to do the algebra to solve for x. But let's just look at it first before we use the algebra and see what's happening. So you're going to look at the difference in the y-intercepts, and that difference is a negative 2 units. So we're going from this 4 to this 2, that's a negative 2 units. And the difference in the slopes is a negative 2/4. So if I take this negative 3/4 for this slope here and subtract a negative 1/4 for this slope here, I get an answer of a negative 2/4. What that means is that these two lines, these two graphs, are moving together at a rate of a negative 2/4 units for every unit along the x-axis of 1 unit along the x-axis. So you move 1 unit along the x-axis, they are now a half a unit closer, or negative 2/4 units. So instead of 2 units, this is 1.5 unit. Move another unit along the x-axis, instead of 1.5 units, this is 1 unit. Another unit along the x-axis, this is now separated by a half a unit. And finally, they intersect at x equals 4, so in 4 units. So that's like saying, how many halves can I get out of these 2 units? Well, it's 1, 2, 3, 4 halves. Or if it's a negative 2, treat it as a negative 2, how many negative 1 halves can I get out of negative 2? And it's the same, 1, 2, 3, 4. So in other words, you go over 1 unit, down a total of a half a unit. So this is down a negative 3/4. But remember, this moves away by a negative 1/4. So that difference is a negative 2/4. So this is a half a unit closer. Move over, go over x, down. This is now a half a unit closer. Move over 1 unit x, a half a unit closer from here to here. And finally, 1 unit x, 1/2 of a unit closer. The lines intersect. So the negative 2, so what you're doing again is you're dividing these negative 2 units by negative 1/2. How many negative 1/2s are there? There are 4. So since both of these are negative, that's the same as multiplying 2 times the inverse, the multiplicative inverse of a negative 1/2. So you're going to change that to a positive. It's a positive 2. So 2 times 2 is equal to 4 units. So the answer for part C y equals a negative 1/4 x plus 2. This is the graph of equation 1. It has a slope of negative 3/4. And for the second equation, this is for part C, you drew a line that went through 0, 2, so this point right here, and the solution to the system of equations, so equation 1 and equation 2, was this point right here, 4, 1. It's where those two lines intersect. And what I want to do is look at a series of lines where their slopes, the difference in their slopes with equation 1 gets smaller and smaller and smaller. And so what happens to the solution, the value of x? So as these slopes, as we go around this circle, each of these slopes, the difference in those slopes with equation 1 is going to get smaller and smaller and smaller as the slope approaches the same slope as equation 1. But look what's happening to the solution. The solution along the x-axis is getting larger. So as that difference gets smaller, it's getting closer to the same slope as equation 1, the solution gets larger. And even when we pass this horizontal line here, so now these are all positive slopes, and so now the slope is negative, but the difference is still getting smaller, and so the solution along the x-axis is still getting larger. So why is that happening? And finally, as we reach the parallel line, remember there are no solutions once the line is parallel because there's no difference. These slopes are exactly the same. But now look what happens as you go past this parallel line. The solution now is way up here. It's a negative value. So here, right here, the solution is a negative x. And now that difference is getting larger. So this solution is getting closer and closer and closer to the y-axis. So why are those patterns taking place? Why is that happening? So I want to add some numbers to this and take a closer look at what's going on. So this is the slope for equation 1. It's a negative 3/4. This is the slope for the parallel line, negative 3/4. And then the answer for part C has a slope of a negative 1/4. Right here's negative 1 for 4 units along the x-axis. So this slope is a negative 1/4. So what's going on? So I'm going to add some numbers to this and take a much closer look at the details. As I put together images to show you the patterns in this problem, I just felt like I was digging myself a deeper and deeper hole. So I ended up with 17 sets of images to show you the different patterns in this problem. So let's begin with the graph of equation 1, and that graph has a slope of a negative 3/4. And so then I drew a circle, and I'm going to look at a series of lines that go through the center, which is at point 0, 2, so right here. So I'm going to start with this line, and I'm going to move one unit over. Let's just call this a unit. Actually, I divide this up into a number of equal parts. And so let's move over 1 unit. And so the calculation, so the first thing is to calculate the slope. So the idea is to find out where is the solution between this graph, this is going to be the second equation, and this graph right here. So the solution for the coordinate of x. So what's x for this point right here? So first of all, calculate the slope. The slope is a positive 5. So 5/2 divided by a negative 1/2. And so here's the difference in the slope from negative 3/4. So the slope of the first equation, the first graph, is negative 3/4. And what's the difference with 5? Well, that difference is a negative 5 3/4. I'm not showing you the calculation of the slope. The slope is 5/2 divided by 1/2. But this is the calculation of the difference. Well, a way to look at that difference is to use a number line. So how far apart are a positive 5 and a negative 3/4? What's the difference between them? And it is that negative 5 3/4. Negative 5 3/4, negative 5 3/4. Now that negative 5 3/4 is the rate at which these two lines, this line right here for graph 1 And this line right here for graph 2, it's the rate at which they move together. So in 1 unit of x, they will move together a -5 3/4 units. Well, but they intersect before x equals 1. So the solution is actually a fraction of 1. So it's how many of these 5 3/4 or -5 3/4 can you get out of -2? Well, you can get out less than 1, and you can get out about 1/3. Because if you think about this, 2, look at this as 2 units, and look at this as close to 6 units. 2 divided by 6, or 2/6, is equal to 1/3. Well, a -2 divided by a -5 3/4, which is close to -6, is also equal to +1/3. So a lot of detail, a lot of stuff going on. So these are the calculations. So the slope for, call this graph 1, call the original equation graph 0. So the slope for graph 1 in this case is a +5. The difference with the -3/4 slope is a -5 3/4. And so now you take those 2 units, it's a -2 units from 4 to 2. So this is a -1, -2. Take those -2 units and divide those by -5 3/4. How many of these -5 3/4 can you get out of this -2? You can't even get one of them. It's too big. You can only get a fraction. It's about 1/3. Here's a little bit more detail on the calculation of that x coordinate. So -2 divided by -5 3/4, change it to -23/4. You multiply by the multiplicative inverse, you get +8 23rds, and that is a little bit more than 1/3. 8 24ths would be 1/3. 8 23rds is a little bit more than that. So back to this graph, see where it is. And so this is about 1/3. And then we're going to move to the next one. So now this next one, notice that the solution, the value of x, the x coordinate, moves to the right. It's a little bit larger. It moves a little bit farther along the x-axis. That's because the difference is a tiny bit smaller. The difference in the slopes is a tiny bit smaller. So this is the first slope. This is the second slope. So this is closer to this -3/4. And we're going to get closer and closer and closer to it. As you get closer to it, that means that the difference is less. So now I'm going to divide these 2 units. So I'm going to divide it by the difference. So -3/4 minus 5/2. So what's a -3/4 minus this 5/2? That is equal to -3 1/4. So this is actually a smaller difference than the previous one. So this is now a difference of a -3 1/4. So +5/2 to -3/4. So I'm going to divide by a smaller value. This is a -3 1/4. So that difference is a -13/4. So how many of these -13/4 can you get on a -2? You can get out more of them. Not quite 1, but it's a larger portion. It's almost 2/3, whereas the first answer was 1/3. Here's a little bit of information on that calculation. All right, so this solution is approximately 2/3 along the x-axis. The first one is about 1/3 along the x-axis. Now let's move to the next one. So what's the next slope? So now this slope is getting closer to the original graph. So the difference is going to be smaller. So you're going to get more of those units out of -2. So x is going to move farther along the x-axis, the x-coordinate, the solution. So this has a slope of 3/2. So what's the difference between -3/4, this slope, and +3/2? -3/4 minus a +3/2. That difference is smaller. It's a -2 1/4. So that difference is smaller. I'm going to divide -2. So here's the -2 1/4. And that difference is smaller. I'm going to divide -2 by a smaller number. That means I'm going to get more of them out of -2. So I'm going to get a larger solution along the x-axis. So it's negative 87 hundredths. So moving a little bit farther along the x-axis. The first one was 1/3, about 1/3. The next one was about 2/3. And this one is 87 hundredths. And so I'm not going to talk much more through this. I'm going to show you the rest of them just slowly. But the point I want to make is I'm going to provide you with PDFs of the whole series that I'm showing you right now, and then also the individual parts. So you can use those PDFs however you wish. I'm going to also provide you with all the images. This is hard stuff, and there's so much going on. I had a lot of trouble figuring out how can I show this to you in some concise way, and I don't think there is a concise way. This is the best I can do at this time. All right, so let's go one more out. So notice that this slope is getting closer to this slope, so it's going to be a smaller difference when you figure that out. So that means a smaller amount taken out of -2. So how many of those can you get out of -2? You can get more of them. In this case, you can get more than 1. So this difference has to be less than -2, right? Because you can get more of these, more than one of these, out of -2. So here's the difference in -1 3/4. Difference is in -1 3/4. So how many 1 3/4 can you get out of 2? Well, you can get more than one of them because it's smaller than this 2. So you can get a tiny bit more than 1. A little bit of information on the calculation. So the x coordinate for the solution is now greater than 1 because it's moved past this 1 right here, because you can get more of the difference, more of those units out of -2, more than 1 unit out of -2. All right, so this is a little bit larger. Slope is closer to -3/4. So that difference is less. So that means I can get more of those out of this -2. So remember, the difference is the rate at which these two lines will move together. So if that difference is small, then it takes more of those units. You can get more of those out of -2 to move to the solution along the x-axis. So this has a slope of 2/3. What's the difference? It's now that difference is smaller, -1 5/12. So the difference is smaller. And so now I can get more of those. This is a -1 5/12. I can get more of those out of -2. So the movement along the x-axis is greater. So I have now moved farther along the x-axis. All right, so I'm just going to scroll through these, and I want you to see that as the slope approaches the first graph, the difference gets less. That means I can divide -2 by a smaller number, and so the answer is going to get larger. Or the answer is going to get farther along the x-axis. So smaller difference, smaller number, dividing -2 by a smaller value, I'm going to get a larger answer farther along the x-axis. So this has moved farther along the x-axis. The slope is getting closer to -3/4, so smaller difference. So now I'm going to divide -2 by a smaller amount. -3/4, I can get more of those out of -2. So that answer is going to move farther along the x-axis. This slope now is really getting closer to -3/4. Now remember, I'm going to give you all of these images in PDFs, so you can scroll through each of them and think about what's going on. So this is a smaller difference. I can get more of those units out of -2, so this is farther along the x-axis. This is the answer to part C. Remember, you drew this line between 0, 2 and 4, 1. So what's the difference in the slopes? It was a -2/4. How many -2/4 can I get out of -2? I can get 4 of them. -2/4 Negative 2 divided by negative 2/4 equals 4. So now I've moved 4 units along the x-axis to this solution, to the x-coordinate of the solution. Keep going. Smaller difference. So now I'm going to divide by a smaller value. So this is going to move farther along the x-axis. Now you can stop the video and look at each one of these, or you can use the PDFs. Okay, moving. So now this answer is going to be, the x-coordinate is going to be very large, because this is almost the same slope as graph 1. So a very small difference, tiny difference, negative 1/12 is the difference. So how many negative 1/12 can I get out of this negative 2 right here? 1, 2. I can get a lot of them. Small, very small difference. So I can get 24 of these negative 1/12 out of negative 2. So that means that you're going to move along the x-axis 24 units until the two graphs intersect, because remember that the difference in the slopes, that negative 1/12, is how far these two lines move together for each unit along the x-axis. Well, it takes 24 of those units for these two lines to intersect, because negative 2 divided by negative 1/12 is equal to 24. And here the lines are parallel. They will never intersect. So the difference is 0. So negative 2 divided by 0, 0 is undefined. There is no solution. Now look what happens as you move past parallel. So now the solution is way over here. It's a small difference, so you can divide negative 2 by a very tiny number, but that number now is positive. So this answer is going to be negative. So the slope is a negative 1. The difference between a negative 3/4 and a negative 1 is actually a positive 1/4. So negative 2 divided by a positive 1/4. Negative 2 divided by a positive 1/4 is negative 8. So now that solution has flipped over to a negative x. So this difference now is getting larger. So I'm going to get fewer of those positive units out of negative 2. So this solution is going to move closer and closer and closer to the y-axis as this difference gets larger and larger and larger. This slope is a negative 3/2. So it's 3 units over negative 2. So negative 3/2. So now this difference is getting larger, but now it's a positive difference. Since it's a positive difference, the answer is going to be negative, but I am moving closer to the y-axis. So this has now gotten closer to the y-axis. The solution is actually right here. The next one, the difference is larger. So it's a greater slope. So that difference is larger. So now it's a positive 7/4. So now this difference has gotten bigger. So now I'm going to divide negative 2 by a larger positive value. And so this answer is going to get closer to the y-axis, but it's negative, because the negative 2 divided by a positive number is negative. Larger difference, larger positive value. So negative 2 divided by a large positive amount is going to be a small answer. So it's very close to the y-axis, just a negative 47/100. Okay, so I have provided in the information below this video a PDF of all the slides that I just went through, and also each part separated out, so you can look at each one of these series separately. So let me show you what that looks like. This is a quick view of the images and PDFs provided for problem number 1. There are 13 different PDFs. The first PDF is just the answers for part A, B, and C. So here's the setup of the problem. This is the first equation. Calculate the slope of the first equation. And then part A is just writing an equivalent equation. So there's an infinite number of solutions. Part B is to write the equation for a parallel line. So there are no solutions. And part C is to write the equation for a graph that goes through point 41, which is the solution for the system of equations. It's the intersection of the two graphs. The second PDF is for part B and shows what happens as the difference in the slopes gets smaller. So as the difference in the slopes gets smaller, the x-coordinate for the solution gets larger. It moves farther and farther to the right along the x-axis. So why does that happen? And then you reach the answer for part B, which is when the lines are parallel, there is no solution to the system of equations. And then when you move past parallel, that x-coordinate in the solution to the system becomes negative. So why is that happening? This is part B. The answer is different y-intercepts, but the same slope. That'll give you a parallel line, and there's no solution to that system of equations. The third PDF is for part C, and it shows how you get from this vertical line right here, and you move along the x-axis till you get to the answer, which is 4, 1 right here. So there's a single solution for the system of equations of this pink graph right here, and the graph for equation number 1, which is this black graph right here. And they intersect at this point, 4, 1. So they're actually PDFs from 3 through 10 have to do with part C. These PDFs show what happens as the difference in the slopes gets smaller. The x-coordinate for the solution between each of these systems of equations gets larger. It moves to the right along the x-axis. So the x-coordinate is getting larger until it goes past parallel, and the difference in the slope of these two lines is 0. And then the x-coordinate to the solution flips over to a negative value, and it starts to get smaller. So why is that happening? So this is part C. And here's the answer once again to part C. The fourth PDF has the 6 images and all 17 sets of those images. So it's huge. It's 129 pages long because I wanted you to see everything together. And so it has this vertical graph, and then it goes to a system of equations for a set. So this is the system right here. This is the second graph, the second equation, and this black line is always the first graph, the first equation. And then I show you the slope of the second graph. You already know the slope of the first graph. It's a negative 3/4. So I show you the slope of the second graph and the calculation of the difference in the slope between the first graph and the second graph. And then that difference on a number line. And then the calculation of x, taking the difference in the slope and dividing a -2 by that difference gives you the value of x, and then more detail on that calculation. And I go back to actually this is the second image that shows you the slope again, just so that you can see where it came from. And then I go on to the next one. So this is the next set. The slope So this would be 5 halves over 1, or a slope of 5 halves. The difference in the slopes between a negative 3/4 and a positive 5 halves. Using that difference, or showing that difference on a number line, then the calculation of x, which is negative 2 divided by that difference, and then more detail on that calculation, so you just can see that, how you get to a decimal value. And then it repeats, goes back to the second image once again to show you the slope, and then it goes on to the next one. Now it's hard to see the patterns showing the image of each set each time. So the next PDFs separate out each image within a set. PDF 5 shows the difference in the slopes is decreasing, so that difference is getting less as I move forward here, and the value for the x-coordinate is increasing. So this slope is actually approaching this slope of the first graph, so that difference is getting less. This is the answer to part C, where it goes through 4(1), so this is the solution to the system of equations, and then that difference is getting less and less and less until it reaches parallel, and so there is no difference, so there is no solution, because these are parallel lines. And then it continues and it flips over to the other side where the x-coordinate becomes negative. So the difference in the slopes is decreasing as this line approaches the same slope as the first equation, or the graph of the first equation, and the x-coordinate is getting larger. So why does that happen? Reaches parallel, so there is no solution, goes beyond parallel, or beyond a difference of 0, and so now the x-coordinate is negative. PDF number 6 shows the lengths along the x-axis and the lengths along the y-axis that you would use to calculate the slope. So the slope of the first graph here is a negative 3 over positive 4, so it's a negative 3/4. It's the slope of the second graph that's in the system of equations is 5 halves divided by 1/2, and that's the slope of 5. This is the slope of 5 halves, and so on. So these are all positive slopes. Then it reaches 0, which has a slope of 0, goes beyond 0. So these are negative slopes, but the difference is a negative value. So this is a negative 1/5, and so it's a negative 3/4 minus a negative 1/5. That gives you a negative difference. So a negative difference until it's parallel. So now the difference in the slopes are 0. So this slope is a negative 3/4, and the slope of this line is a negative 3/4. So that's a difference of 0, goes beyond parallel lines. So now the difference in the slopes is a positive difference. So now you're taking negative 2 and dividing it by a positive number, so you're going to get a negative x-coordinate up here. This is different ways of calculating that slope. You can calculate the same slope. So this is a slope of negative 1, or you could use these lengths here, slope of negative 1. Different way to calculate the same slope, a slope of negative 3/2. Different ways to calculate the same slope, and so on. And so now this is a slope of negative 5, and so that difference is a positive value when compared to negative 3/4. So it's a negative 2 divided by a large positive number, and so this x-coordinate is negative. PDF 7 shows the calculation for the difference in the slopes. And this difference starts out as a large negative value, and it gets smaller and smaller and smaller. It decreases as the difference, of course, decreases between the blue lines and the original black line. And as that difference gets smaller, and it's a smaller negative difference, that means that the calculation of x gets larger. The x-coordinate gets larger. So the difference gets smaller, The x-coordinate gets larger as it approaches a parallel line with the black line. It's getting closer to the black line, and so now it's parallel. This is the parallel line right here. The difference is 0, so there's no solution. But right before that, the difference is a very small negative value, and so that means that x is going to be a large positive value. So the x-coordinate is going to be very large, and it's going to be positive. And then once this flips past this parallel line here, the difference is going to be a small positive amount, which means that x is going to be a large negative, large in magnitude, negative value. So it's going to be way up here, but that x-coordinate is going to decrease in magnitude as and approach the y-axis as this difference gets larger and larger. So now it's small, and then it gets larger. And so this difference, this calculation of x, gets smaller in magnitude and approaches the y-axis. PDF 8 shows the difference in the slopes on a number line. So this difference in the slope starts out as this is the slope of the first equation. The graph of the first equation is -3/4. The slope of the graph of the second equation is a +5. That difference is a -5 3/4. So a large negative amount, that means the x-coordinate is going to be a small positive value. And as this difference decreases, as those lines approach the same slope as the first equation, the graph of the first equation, this difference gets smaller, it decreases. That means the x-coordinate is going to get larger and has a positive value. So the difference gets smaller, the x-coordinate is getting larger. So that difference is a smaller negative value. The x-coordinate is a larger positive amount. Then it reaches the parallel line, or the difference is 0. So there is no solution. And then once it goes past a difference of 0, now that difference is a +1/4. It's a small positive amount. That means the corresponding x-coordinate is going to be a large negative value. And that's going to decrease in size, the x-coordinate, as the difference gets larger as a positive amount. So this difference is getting larger as a positive value. That means the x-coordinate is getting smaller as a negative amount, and it's approaching the y-axis. PDF 9 shows the calculation of the x-coordinate. So as this difference gets smaller, so it starts out a large difference between a -3/4 for the original graph and a +5 for graph number 1. That is a large negative difference. So -2 divided by a large negative value is going to give you a small positive amount for the x-coordinate. And that difference is going to decrease. So this difference is getting smaller. And as this difference gets smaller, then this x-coordinate gets larger. It's a -2 divided by a smaller negative amount. And so this x-coordinate is getting larger as a positive value. Until it reaches the parallel line, which the difference is 0, and this is undefined. There is no solution. And so now the difference is a small positive amount. So a -3/4 minus a -1 is a +1/4. So -2 divided by a small positive value is going to give you a large negative x-coordinate. But this difference now is going to get larger. It's moving towards, the lines are moving, the slope is moving towards the y-axis. So this difference is getting larger as a positive value, which means that the corresponding x-coordinate is going to get smaller as a negative value. So this is getting smaller, it's moving towards the y-axis. PDF 10 is the same as PDF 9, but just with more detail on this calculation to get to this decimal value for the x-coordinate. Just showing you how I'm doing the calculation. Again, the difference decreases, the x-coordinate increases, then it flips to a positive difference, and the x-coordinate is a negative value, and that's going to decrease towards the y-axis. PDF 11 is the summary table of the information shown in Part C. So this is the original graph, equation 1, which has a slope of a -3/4. And this is all the other graphs. And so all those other graphs have a decreasing positive slope until it gets to 0, and then an increasing negative slope beyond 0. The difference in the slopes is decreasing, decreasing, decreasing as negative values until it reaches a -3/4. And then it switches to increasing positive amounts beyond this -3/4. The x-coordinate is increasing, increasing, increasing as a positive x-coordinate reaches 0 here, undefined or no solution, and then starts to decrease as a negative x-coordinate as it approaches the y-axis. So there's a short separate video on this. PDF 11 also shows dividing 2. Now the difference in the y-intercepts is a -2 units. So it's useful to look at dividing those -2 units. So I just chose to look at it as just dividing 2. But dividing 2 by smaller and smaller amounts, and look what happens to the answer. Look what happens to the, in this case, which would be the x-coordinate. The x-coordinate would be getting larger and larger and larger in size as you divide by a smaller and smaller amount. So I'm going to go through this. There is a separate video on this showing how this division works. PDF 12 shows a choice that you have when you set up the algebra. So you can either choose to work with all the x terms on the left side of the equation like this, or choose to work with the x terms on the right side of the equation like this. That choice will determine whether or not you work with negative numbers when you calculate what x is, or positive numbers when you calculate what x is. Either way, you're going to end up with x equals, in this example, x equals a positive 4 4/5. And there's a short video that goes through this. Finally, PDF 13 is a supplement that shows writing equivalent equations. So part A of this problem set is showing or writing equivalent equations so that you have infinitely many solutions. They're the same line. And so if you do that, you have to end up simplifying both equations so that you can show that they are equivalent. So you're going to use properties of mathematics. And I have a video that shows this. And you also have this PDF where you can go through this much more slowly, but you get down to the point where x equals x. And that shows you that these two equations are equivalent and you have infinitely many solutions. Whatever you choose for x is going to be the value for x in the second equation. And this is just showing that those equations are equivalent by graphing, so you end up with the same line. Now I took the easy way out. I just wrote an equivalent fraction as the slope. And so I wrote two different equations. These have infinitely many solutions. But there are different ways to write equivalent equations. And I think more interesting ways and better ways to understand the algebra. So I'll go through this. This is a second way, using the distributive property. And this is again using the distributive property. You often see this, where they'll write this form up here, a -3/4 times x plus 4 plus 7. Now nowhere does it teach you how to do this. And so I'm going to try to do that in this video with this PDF.